Welcome, everyone. Today we are going to explore the modern delivery flywheel. This presentation focuses on how trunk-based development and feature toggles serve as the primary drivers of elite engineering performance. We will examine how these practices create a powerful, self-reinforcing cycle that allows teams to increase their deployment frequency while simultaneously reducing risk. Let's dive into how these methodologies work together to accelerate your development lifecycle and build long-term momentum. The primary goal we are striving for is making software always deployable. Continuous delivery is a software engineering approach that ensures our code is constantly in a state where it could be released to production. The core objective here is to reduce the cost, time, and risk involved in delivering changes, which in turn enables more frequent deployments to validate our product direction. This approach is built on 5 core principles. We must build quality in from the beginning, work in small batches to increase flow, and let computers handle repetitive tasks while humans focus on solving complex problems. Furthermore, we must relentlessly pursue continuous improvement and recognize that everyone is responsible for the delivery process. As you can see in the pipeline diagram, the process flows from the initial commit through acceptance testing, exploratory sessions, user acceptance testing, and staging, before finally landing in production. The ultimate aim isn't just about speed. It is about creating a robust system where releases are routine, low-risk events rather than high-stakes dramas. Historically, the belief was that deploying code to production was inherently risky, leading teams to bundle features into large, infrequent releases to mitigate that risk. This approach, however, slowed down velocity and created a false choice between speed and stability. The DevOps Research and Assessment Program, or DORA, has demonstrated that this is a false dichotomy. High-performing teams do not trade speed for stability. They achieve both. By implementing the same set of effective practices, these teams consistently outperform low performers on key metrics. The organizational impact is clear. High-performing teams are twice as likely to meet or exceed their organizational goals and see 50% higher market cap growth over 3 years. Additionally, they spend 11 percentage points more time on new work versus rework. As shown in the chart, high performers consistently lead across all categories, proving that excellence in delivery drives superior business outcomes. In traditional branching models like GitFlow, developers typically work on new features in isolated, long-lived branches. While this is meant to provide isolation, it creates significant friction. The longer a branch lives, the more it diverges from the main branch, leading to complex merge conflicts and hard-to-debug issues, often referred to as merge hell. Furthermore, this model introduces management challenges, requiring complex workflows to map branches to environments and necessitating retesting as features merge upward. Data from a survey of Brazilian developers highlights this issue. Although branch-based workflows are widely used by 84% of respondents, they are notoriously prone to conflicts when branches have long lifespans, which lengthens the overall development cycle. If we look at the comparison of methodologies, the old way is visually chaotic. It depicts multiple overlapping branches for development and features that eventually result in merge hell. On the right, the modern way illustrates a trunk-based approach. By focusing on smaller tasks and frequent merges directly back to the trunk, we achieve simplicity and a more direct path to production. This modern approach reduces overhead and minimizes risk through continuous integration. Let's examine the foundation of a modern development environment, creating a single source of truth through trunk-based development, or TBD. In this model, all developers collaborate within a single branch known as the trunk. This approach serves as the essential cornerstone for a true continuous integration practice. The primary benefit of TBD is that it avoids drift between various development branches, effectively preventing the frustration commonly known as merge hell. By working in one shared space, teams ensure that everyone is constantly aligned. This leads us to the golden rule of the practice. The trunk must never be in a state where the continuous delivery process is unable to deploy it to production. To achieve this, all code is checked in, built, and tested constantly, ensuring the codebase remains deployable on demand. Furthermore, TBD enables significantly simpler workflows. It eliminates the need to build and maintain multiple branches in parallel, map them to specific environments, or retest features after they have been merged. This reduction in overhead is critical for managing complexity, especially within a microservices architecture. As highlighted by the Go CD blog, the core takeaway is that you should never find your trunk in a state where your CD process is unable to deploy. Maintaining this constant state of readiness is what allows for rapid, reliable, and high-quality software releases. Trunk-based development presents a unique challenge that many teams struggle to reconcile. If our core philosophy is to have all developers commit their changes directly to the main trunk multiple times a day, and we maintain that the trunk must always remain in a deployable state, we face an apparent contradiction. The central question is this: how do you safely commit unfinished features or work-in-progress code without breaking the build or accidentally shipping incomplete functionality to your end users? Consider this real-world scenario. A team is currently working on 4 key features: search, menu, sign-in, and a brand new in-app chat. While search, menu, and sign-in might be ready, the chat feature is still very much a work in progress. Under a trunk-based development model, the code for this incomplete chat feature is still checked into the trunk alongside the stable features. This leads us to the heart of the challenge. How is this possible without compromising production stability? Solving this paradox is essential for high-velocity teams who want to avoid the integration hell of long-lived feature branches. The central solution to modern software delivery lies in decoupling deployment from release. Traditionally, many teams operate under the assumption that deploy equals release, but breaking this link is essential for high-performing organizations. By separating these two concepts, we can have new code existing in a production environment, deployed, without it being executed or visible to users, released. This technique is often referred to as a dark launch. This separation of concerns creates a critical safety net, allowing us to move quickly while maintaining system stability. This approach aligns with a core architectural principle from the 12-factor app, which mandates a strict separation between 3 distinct stages: build, release, and run. In the build stage, source code is converted into a compiled artifact. In the release stage, that artifact is combined with a specific configuration for a target environment. Finally, in the run stage, the application is executed. A key takeaway of this model is that once an application is in the run stage, it is immutable. It is impossible to make changes to the code at runtime. This discipline ensures consistency and reliability across the entire delivery pipeline. Feature toggles, also known as feature flags, serve as the primary mechanism for decoupling software deployment from product release. At their core, these toggles are simple conditionals, such as if-else statements, that determine which code paths are executed at runtime. By utilizing this approach, we can enable or disable specific features without modifying the source code or requiring a full redeployment of the application. This effectively solves the paradox of wanting to deploy frequently while maintaining a stable user experience. An incomplete feature, like the in-app chat shown here, can be pushed to production while remaining hidden behind an off state. It stays invisible to users until it is fully developed, tested, and ready for launch. As illustrated in the code snippet, the application simply checks the status of the toggle. If enabled, the chat UI is rendered. If not, the functionality remains dormant. This allows teams to suppress the manifestation of unfinished features in production until they have been sufficiently validated in pre-production environments. Feature toggles represent much more than just a release mechanism. Once a toggle framework is integrated, it can be leveraged for a wide array of strategic purposes, each defined by a specific operational lifecycle. Release toggles are used to manage access to unfinished code. These are temporary and should be removed immediately after a feature is fully released to ensure the codebase remains clean and free of technical debt. Ops toggles provide control over production code behavior. These are typically long-lived and allow for rapid intervention, such as disabling a malfunctioning feature or managing system performance during peak traffic by offering a degraded user experience. Permission toggles allow us to enable specific behaviors for privileged users or manage customer entitlements. This ensures that specialized features, such as administrative tools, are only accessible to those with the appropriate rights or subscription levels. Lastly, experiment toggles facilitate A/B testing and canary launches. They allow teams to test how well a new feature is received by a small segment of the user base, providing critical performance data before deciding whether to make the feature a permanent part of the product. Feature flags are dynamic code, representing a significant shift from traditional static configuration. It is crucial to understand that a robust feature flag system is much more than just a simple configuration file. The first major differentiator is runtime evaluation. Unlike standard config files, which often necessitate a redeploy or a system restart to take effect, feature flags in a managed platform are evaluated at runtime. This means any change is reflected nearly instantaneously across your application. The second key advantage is precise targeting. While config files act as blunt on-off switches for your entire user base, feature flags allow for sophisticated targeting rules. This enables you to roll out features to specific segments, such as internal testers, beta users, or specific geographical regions, significantly reducing risk and allowing for controlled experimentation. However, we must also be mindful of managing flag debt. Feature toggles are a form of technical debt that must be actively managed to prevent complexity from spiraling out of control. To maintain a healthy codebase, release toggles should be short-lived and discarded immediately once a feature is fully live in production. Additionally, as your implementation scales, utilizing specialized tooling becomes essential. Managing hundreds of toggles requires clear visibility into which flags are active across each of your environments to ensure long-term system stability and performance. The data presented here provides clear evidence that trunk-based development, or TBD, is strongly correlated with smaller, more experienced engineering teams. A comparative analysis of Git workflows reveals two distinct trends that define how these models are adopted in professional environments. First, regarding team size, we see that TBD is the preferred choice for smaller, leaner groups. The median team size for TBD users is just 3, whereas branch-based models show a higher median of 5.5. Perhaps most telling is that within this study's sample, every team with more than 20 developers utilized a branch-based model, suggesting that TBD becomes increasingly difficult to manage as team scale grows. Second, we examine the experience levels associated with each workflow. On average, TBD users are more seasoned professionals, with a median of 10 years of experience compared to 7 years for those using branch-based workflows. The mean experience for TBD users also sits higher, at nearly 12 years. In summary, trunk-based development favors fast-paced projects powered by small, senior teams who can manage the high frequency of integration. Conversely, branch-based development appears better suited for larger or less experienced teams, even though it introduces its own set of management challenges.
The modern delivery flywheel represents a self-reinforcing system where core development practices work in concert to create a virtuous cycle. These are not merely isolated tactics. Instead, each element strengthens the others to build unstoppable momentum in our delivery process. Starting at the top, trunk-based development simplifies the codebase by encouraging developers to work on a single shared branch. This foundational practice enables true continuous integration, characterized by small, frequent merges that prevent the integration challenges common in traditional development models. To ensure it is always safe to merge work, even when it is incomplete, we utilize feature toggles. This capability is essential because it decouples the deployment of code from the release of features. By separating the technical act of moving code into production from the business decision of exposing features to users, we significantly reduce deployment risk. These lower-risk deployments allow us to move towards shipping in small batches with high frequency. This rapid delivery cadence provides immediate, rapid feedback, which improves overall software quality and further accelerates the pace of development. Each rotation of this flywheel builds upon the last, creating a highly efficient and resilient delivery ecosystem.
The modern delivery flywheel is not a new invention. Rather, it represents the practical fulfillment of principles established nearly a decade ago through the 12-factor app methodology. Several of these factors are inherently supported and enhanced by modern delivery practices. Factor 3 focuses on configuration, emphasizing the storage of settings, such as feature toggles, within the environment rather than the code itself. Factor 6 addresses processes, advocating for executing applications as stateless processes. This is significantly simplified when features can be toggled on or off without changing the running process. Finally, Factor 10 highlights dev-prod parity. Toggles enable the exact same build to run across all environments, with only the configuration differing between them. Looking ahead, a 2021 master's thesis proposed extending this methodology with new factors for modern cloud apps, including API-first, telemetry, security, and automation. All of these additions are fundamentally enabled or significantly enhanced by the continuous delivery flywheel.
Elite performance is the ultimate payoff for teams that master the delivery flywheel of trunk-based development, feature toggles, and continuous integration. Far from making a trade-off between speed and stability, these teams leverage a system that generates both simultaneously as a standard outcome. The data behind this elite performance is defined by 4 key metrics. First, we see a lead time for changes of less than 1 day, paired with a deployment frequency that is on demand, occurring multiple times per day. Crucially, this speed does not sacrifice reliability. These teams are able to restore service in less than 1 hour, while maintaining a change failure rate between 0 and 15%. Ultimately, this evidence dispels the common myth that moving faster is inherently riskier. The data proves the opposite. Slowing delivery in an attempt to increase stability is a mistake, as slow delivery cycles are actually more likely to result in unstable systems. Build the system, not just the features. Adopting a modern delivery flywheel represents a fundamental shift in our approach, moving away from a singular focus on feature output toward engineering the system of delivery itself. When we optimize the system, the results are immediate. We reduce friction, minimize rework, and lower deployment stress across the board. Most importantly, this shift frees our developers to move beyond repetitive tasks and focus their energy on creative problem-solving and true innovation. The cultural impact is equally significant. High-performing teams operating within these systems are 2.2 times more likely to recommend their organization as a great place to work. Our ultimate goal is to create an environment where the right way to build software is also the easiest way. By establishing this flywheel, we ensure that continuous improvement becomes the path of least resistance.